Okay. Yeah. Morning once again. In last class we discussed 8.1 complete, right? And 8.2 in class was discussed, right? Everyone. 8.2 in class was discussed. We studied solubility and solubility product. Okay. This is so we completed this chapter. Okay. We studied the concept of solubility and solubility product. So today we are going to discuss the module. Okay, right everyone? So 8.1 was complete. We have completed both in class as well as homework. Okay, 8.2 in class was covered, right everyone? 8.2 in class was done. Okay, so we will discuss homework of 8.2. Okay, now when we talk about homework of 8.2, now tell me everyone, question number 1, 2, 3. I guess none of you might have issue with question 1, 2, 3, or is anyone having doubt between question number 1, 2, 3? Tell me. Anyone having doubt in question number 1, 2, 3 homework? No doubt? Okay. Anyone? You can ask. Mansi, Chulika, Anjali, Samya, Vivek. Vivek is here. Tulip, Sumaya. Question number 1, 2, 3 of homework. Okay. I guess no one have doubts. Still, I'll just explain the concepts, right? So in this one, concentration of, see, first thing that you should know is what is this? What is the component? Now, when we talk about the component, this is weak base, okay? Only weak base, nothing else, right? So what we use to, sorry, what concept we need to use? We need to use the concept of, yes, weak acid, distillation of weak acid. Okay, right? You have to calculate Kb, right? Now, concentration is given, which is basically 0.1 divided by 10, right? This is the concentration. Concentration of OH minus is given, right? Okay, you have to find Kb. So we know that Kb is equal to concentration of, or you can just say C alpha, right? Square, right? Kb is equal to C alpha square, and we know that C alpha is equal to concentration of OH minus, right? I'm just using the formula, okay? I'm just using the formula, okay, everyone? Or you can just, right? So you can see that Kb is equal to C alpha whole square by C. So it is concentration of OH whole square by C. So concentration of OH is given as well as C is given. Right, everyone? Okay. So this was question number 1. Now question number 2 again, right? So for this, what is this? This is hydrolysis, yes or no? Right? Okay. Now tell me, what is the answer of this one? It is very easy. It is just the reverse. No, yes. See, Ka is given, right? You are asked to find Ka. Sorry, Ka you have to find, because this is Kh now. This is hydrolysis equation, right? So Kh is given, right? Kh is 5.55 into 10 power minus 10. And you are asked to find Ka. So is there any relationship between Kh and Ka? Yes. If you remember, Kh is equal to Kw by Ka. So Ka is equal to Kw by Kh. Right? Formula putting getting. Yes, Kh is equal to Kw by Ka. Formula putting getting, right? Question number 2, done, right? You have to see the reaction. The first thing that you should know, what is the reaction? Now in this one, again, weak base, right? Right? Now, Kb is given. Calculate the concentration of this, okay? Now, obviously you have to find concentration of this. So concentration of this is equal to concentration of OH minus. As simple as that. Right, everyone? Tell me, right? Okay, and we know that concentration of OH minus is equal to concentration of this CH3CU, right? CH3 whole thrice NH4 plus, which is equal to root Kb into C. As simple as that, right? Kb is given, C is given. You can find it, formula putting getting. So first 3 was formula putting getting. Right, everyone? Okay. Now level 2. Level 2, 4 to 8. Level 2, 4 to 8. Tell me, everyone, any doubts? Any specific doubt between 4 to 8? Okay, I'll just explain all the question because you guys are shy, I guess, or haven't solved the problem. Okay, so the ionization concept of phenol, right? Phenol. So phenol can be treated as weak acid. Okay, it will release this H plus. So this is what? Ionization constant, which is K is given. What is the concentration of phenolate ion? In 0.05 molar solution of phenol. Now, tell me, right? Tell me, this is again the same problem, right? This is again the same. Ka is equal to this phenolate ion because it is your product, O minus into H plus divided by CH3, sorry, C6H5OH. As simple as that, right, everyone? This is the basic formula. Agree? Right? Now we know that in this, we know that what is given? We know that the concentration of this is equal to concentration of H plus, right? Because obviously C alpha, and concentration of H plus is equal to root Ka into C. Right, everyone? Tell me, right? Yes or no? So, got this easy formula putting getting? Okay, now, what will be the degree of ionization if the solutions also have 0.01 molar of Hi? Okay, so again now we have this common ion, right? Hi is common ion because it will release H plus, and we know that since Ka is very small, Ka is very small, right? H plus released from this will be ignored. So if you talk about H plus total, right? H plus total will be equal to what? This one 0.01 plus C alpha dash, but I'm saying that this C alpha dash is very less as compared to this. Now, you can write it like this again, K is equal to concentration of H plus into C alpha divided by C 1 minus alpha. Again, CC will get cancelled, so it alpha dash, right? Now, concentration H plus is already given, which is 0.1. So, alpha dash is equal to Ka by 0.01. Okay, everyone, tell me, did you get this concept? Did you get this concept? Yes or no? Tell me. Right? Okay. See, I'll explain once again. First, this one, right? The first part. First part is easy, formula putting getting. First part is easy, formula putting getting. Now, second part. Now, in second part, Hi is added. So, Hi will act as a common ion, yes or no? Hi will act as a common ion. Now, whenever we have a common ion, right? So, which is your common ion? First, you have to think which is your common ion. So, obviously, your common ion is H plus. Right, everyone? Common ion is H plus. So, H plus will be produced by both Hi and this phenol. So, total H plus will be 0.01 from this phenol, sorry, Hi, and C alpha dash, which is new concentration of H plus, right? New concentration of H plus from what? From, yes, right? New concentration of H plus from phenol. Okay, everyone, right? Now I can say that since this C alpha dash will be negligible as compared to this 0.01, right? So concentration of H plus can be taken as just 0.01, which is the concentration of H plus produced by Hi. Now, again, the Ka will not change if the concentration is changed. What is the formula of K? K is equal to concentration of H plus into concentration of finite ion, which is C alpha dash, because again, right, the degree of dissociation will change now. C alpha dash divided by concentration of C6H5OH, which is C bracket 1 mass alpha dash. Now alpha dash, again C alpha dash, CC will get cancelled, the alpha dash will get tends to 0. So we are left with Ka is equal to concentration of H plus into alpha dash. So alpha dash is equal to Ka divided by concentration of H plus. Got it, Sanya? Tell me, got it? Everyone got this? Question number 4. Okay, right? Very good. Now let's see question number 5. If you see question number 5, again, the pH of vinegar solution is given, means concentration of H plus is given, right? And pH is given. This vinegar is an aqueous solution of acetic acid. Okay, yes, no issues. pK is also given with density this. Okay, what mass percentage of acetic acid is in the solution? Now you have to find concentration. Tell me yes or no. So what is the formula? pH is equal to half pKa minus log C. Okay, so from here you can find concentration, right? So if you can find concentration, you can find mass because density is given. Okay, then you can find mass percentage. Okay, right everyone, right? Tell me yes or no. After you find concentration, which is right moles per liter, you can find what? Weight, right? Because you will just multiply by the molecular mass, weight per liter, and this is given, right? Density is given. Okay, right everyone? So you can find the weight percentage. Okay, next one, C6, question number 6. Determine H3O plus and CH2CO minus, and again this is formula putting getting, K given, right? Concentration given, formula putting getting. Okay, which is concentration of H plus is equal to root K into C. Now also determine this, again same formula, concentration of H plus will be just the concentration of H plus given by this HCl because of common ion, right everyone? Tell me, right? Yes or no? Just raise your hand. Yes or no? Because HCl is a strong acid, right? So this is a mixture of weak acid and strong acid. So we studied that if we have a weak acid and strong acid, then I can say that we will have a common ion effect and the concentration of HCl, right, will be equal to concentration of H plus. Okay, right? Okay. Now seventh one, let's see question number 7. The ionization constant of propanoic acid. Again, this is a weak acid. This is a weak acid. Weak acid. K given. Calculate the degree of ionization of acid in 0.05 mole of solution. Also its pH. Again, alpha you are asked to find. C is given. So what's the formula? Alpha is equal to root K by C. Formula putting getting. Right? Then pH. Again, formula putting getting. What will be degree of dissociation? In 0.101 mole of HCl. Go back to question number 4. Same concept, right? Same concept as in question number 4. Okay, right everyone? Any doubt till question number 7? Tell me. Tell me everyone, any doubt till now? Okay, very good everyone. Now let's see question number 8, right? Let's see question number 8. Now when you talk about question number 8, again See, I hope all of you are getting the concept, right? The first thing that you have to see, what is your component, right? So again, weak base, this is concentration C is given in the presence of NH4Cl. Again, in this case, NH4 plus common ion, right everyone? Because NH3 plus H2O gives what? Gives NH4 plus OH minus. So again, common ion, right everyone? Tell me yes or no. Right? So in this case, Kb is also given. So first thing first, right? pH. So obviously we know that the concentration of OH minus, right? Concentration of OH minus would be what? Tell me. Tell me everyone, concentration of OH minus. Again, formula putting getting na, right? This concentration of OH minus, again formula putting getting, right? No, right? It's not formula putting getting because we have a common ion here, right? So you should not use formula putting getting. You will have a wrong answer. Why? Because Kb is equal to concentration of NH4 plus into concentration of OH minus divided by concentration of NH3. Right, everyone? Now, when we talk about the formula was derived when NH4 plus was also same as OH minus. Now, it is changed. So, Kb is given is equal to concentration of NH4 plus, which is equal to this concentration. Again, by this concentration, because common ion. So 0.01 into concentration of OH minus divided by, now this is also concentration of NH3, which is C minus C alpha, right? But since C alpha will be very less, I can just ignore it. I can just write it as 0.01 only. Tell me yes or no. Tell me everyone. Tell me yes or no everyone. Yes, so concentration of OH minus is equal to Kb only, right? Agree? Agree? Easy question. Is there any mistake? Okay, right? So concentration of OH minus is equal to Kb only. Now, alpha is equal to Kb by C, right? Or concentration of OH by C. Concentration of OH by C. So that's why I have written Kb by C, because their concentration of OH is equal to Kb. So 1.8 into 10 power minus 5 divided by 0.01. So 1.8 into 10 power minus 3. Got it everyone? Tell me. Easy. Now, if you find pH, right? If you find concentration of OH minus, you can find pOH, right? Subtract by 14, you can find pH. Anyone have any doubt till question number 8? Tell me everyone. Anyone have any doubt till question number 8? Tell me everyone. Sneha, you have doubt? Anyone have doubt till question number 8? No? Okay, very good. Now let's see question number 9 and 10, right? 9, 10, 11, 12. Okay, level 3. Now see level 3, right? Now think about this. A handbook states that solubility of methylamine. Now tell me, what is this? What is this compound? Again, weak base. In what is 1 atm ratio, 27 degrees centigrade is 984 volumes of this per volume of water. Okay, right? Now what is given? This is a good question, right? This is a good question. What is given? Think about this, right? Now, N is given. No, N you have to find, right? But 984 volume of CH3 and H2 per volume of water. Okay, now this is, if you talk about what is this? We know that for gas, number of moles and the volume ratio, right, are same. Okay, so N by V, right, is equal to P by RT, right everyone? N by V is equal to P by RT, formula, right, Ariga's equation. Okay, now we know that this P, what is this P? Tell me. It is 984 per liter per volume of water, right? Per volume of water. Okay, right? 984 per volume of water. So N is equal to or per volume of water. Okay, so it is equal to how much? It is given as 984. Okay, right? 984 divided by RT, which is 0.082 into 300, right? Okay, this is N by V, right? Now that was the difficult part, right? How to find it. Okay, that was the difficult part, how to find it. Okay, because this question was bit confusing, right everyone? That what is the value of, sorry, what is the use of this? What's the meaning of this? Okay, right? So this is the amount, basically it is the amount that can be dissolved per volume. Okay, right? So if you calculate this, you will get the value, the number of moles, right? Or basically it is the concentration which can be dissolved, right? So this is the concentration which can be dissolved. This is the concentration, okay, right? Now, C is given, C, if you solve this, we will get C, okay? Now, we will have what? PKB is given, okay? PKB is given. So, we can find POH, POH, first one, POH is equal to half PKB minus log C, right? C you can find using this and PKB given. So pH is equal to 14 minus this, right? Now, what molarity of NaOH would be required to yield same pH? Now, from here pH is calculated. Now we know that NaOH is strong base. So if pH is suppose X, so POH will be 14 minus X. So concentration of OH minus will be 10 to the power 14 minus 14, sorry, 10 power 14 minus X, right? Minus. Okay, right? Now this would be the concentration of NaOH because it is a strong acetal base now, right? It is strong acetal base, right everyone? Tell me, yes or no? Okay, right? Yeah, it's bracket. Okay, it's bracket. Okay, so that is question number 9. Okay, now question number 10. Let's see question number 10. Step by step. These questions you should go at home and see once again. Calculate the degree of ionization of, again, C is given, weak acid given, right? Okay, and this, okay, for this one, Ka is known, which is 1 point, K is missing, 1.8 into minus 5, right? For, right? was missing, right? So Ka is 1.8. Okay, no, it's given, right? So it is this. So first one, 0.01 mole of HCl. So again, strong acid. Common ion effect, yes or no? Yes or no? Yes. So again, we have already solved Ka is equal to concentration of H plus into concentration of ACO minus divided by concentration of ACOH, which is equal to H plus will be given from this HCl, which is 0.01 into this ACO minus is C alpha dash by C minus C alpha dash. C alpha dash will get cancelled. C and C will get cancelled. So alpha dash you can get. Yes or no, everyone? Tell me yes or no. Right? Which is again, if you remember, we have done the same thing in the last class problem. Ka by C. Alpha dash is Ka by C. Okay? Now second one, 0.01 molar of ACONA. Now this is your salt, right? This is your salt. Okay, right? Now if you think, sir, we have salt, we have acid, will buffer solution. No, it won't be a buffer solution, right? Why? Because the concentration is not same, right? The concentration is 50 times, how many times? Right? Concentration is around 20 times, right? No, two times. Sorry, 2 times. So see, technically it can be a buffer, right? But again, this is not a buffer question, so we won't be thinking like that. Okay. And even if you think like that, it won't have any difference. So K will be concentration of H plus into concentration of ACO minus. Now in this case, we have a concentration of ACOH. In this case, ACO minus is taken as 0.1. Okay, right? Right, everyone? And concentration of H plus is C alpha. So same formula, right? Same formula. So in this case also C alpha dash is equal to Ka into concentration of H plus divided by concentration of ACOH, which is C minus C alpha dash. This is also C alpha dash. C will get cancelled, right? Okay, so you can, sorry, this is um, made a small mistake while writing. So alpha dash is equal to Ka, okay, right everyone? Alpha dash is equal to, okay everyone? Okay, so question number 10 solved. 11, let's see question number 11. Now question number 11 is easy and is based on the formula that number of moles will not change. So M1V1 is equal to M2V2. Right? Apart from the equilibrium concept, we have to use this only. How much water must be added to 300 milliliter so the degree of dissolution of acid is double? So alpha, first calculate alpha, which is basically root Ka by C. This is C old one, right? C old one, C1, right? Now alpha dash, which is root Ka by C2, and it is given that alpha by alpha dash is equal to how much? 1 by 2, which is basically root, tell me, C2 by C1. Okay, right? Right, everyone? Then we will use M1 is equal to M2V2 also. Anyone have any issues? Tell me. Anyone have any issues? Tell me yes or no. Anyone have any issues? 1 by 4 is equal to C2 by C1, right? So C2 is equal to 1 by 4 into C1, which is, tell me, this into this, okay? Okay, or here M is C only, na? M is concentration only, right? So you can find V2 because C1 is M1, C2 is M2, V1 is also given. So you can calculate V2, right? Now next question number 12. Not tell me question number 12. Everyone, question number 12. I hope everyone can solve question number 12 now. Because see, right? If you see this, it is same as 10 to the power minus 81. Concentration 10 to the power minus 81. It is same as like that, right? Yes or no? It is same as like that. Okay. Strong acid, right? With, tell me, low concentration. Okay. So you have to take the concentration H plus from water also. That's it. You have to take H plus from water also. Okay. Right. So 8.2 over everyone 8.2. Anyone have any still have any doubts in 8.2? Take your time, take 2 minutes, 3 minutes, whatever time you want to take. No doubts, everyone? No doubts? Just raise your hand. If you have no doubt, please raise your hand. Everyone, please raise your hand. Okay. You can go through the video once again. Okay. And anyways, I'll just share the solution after the completion of chapter. Okay, very good, everyone. Right, Mansi, Anjali, see, even if you don't understand level 3, no issues. At least level 1, level 2, need student, right? At least level 1, level 2 should be clear. Okay, level 3, if you don't get, no worries. Okay, because it is for advanced. Okay, everyone? Now, in this one, right? In this one, the concept of indicator was left, right? The concept of indicator was left because titration will study in detail in redox. Okay, this titration topic, okay, this titration topic we will study detail in redox. Because what is titration? Do not get scared by this word. Okay, titration is a fancy word for neutralization. Okay, that's it. So because this word itself gave a like redox, will complete redox Abhiram, then we will go to inorganic. Okay, we will, sorry, organic. We will complete redox first. Okay. So we will try to complete redox. Redox will take less time only. Okay, right? Okay, right? So this titration and indicators, right? There are two topics which are left, titration and indicators. Okay, and indicators, right? So I will complete this, okay, along with redox. Okay, so we have already covered these topics. Now let's see in class exercise. We have done illustration, I guess. Now, question number 1, anyone have any doubt in question number 1? Tell me. As I said, the first thing that you should do is guys, anyone have any doubt in question number 1? No? Right? Formula putting getting? Right, everyone? What is the formula for buffer? pH is equal to pKa plus log salt by acid. I hope everyone remember this formula. Tell me yes or no. Everyone remember this formula? concentration of acid is given, concentration of salt is given, right? Right, everyone? No, no. Why? Because concentration is number of moles by total volume. What is the total volume? You have to add, right? Total volume will be 1 liter, right? So that's you have to think, right? This is not the concentration. Calculate the number of moles of acid, number of moles of salt, and total volume will be 700 plus 200 plus 100. Okay, right? Then it is formula putting getting. Now question number 2, 3, question number 2 to 7. Anyone have any doubt? Guys, please ask. Question number 2 to 7. Anyone have any doubt? Okay, let's see question number 2. A certain weak acid, right? Okay, now dissociation constant is given, means Ka is given. What's the equilibrium constant for this reaction with a strong base? Now tell me, what's the equilibrium constant of its reaction with strong base? So acid plus base is which reaction? Tell me, acid plus base is which reaction? Tell me, everyone. Tell me, weak acid plus strong base will give me what? Tell me, salt of weak acid, yes or no? Yes or no? Tell me, everyone. This question is tricky and conceptual. Now, salt of weak acid, right? What will happen to salt of weak acid? Tell me. This is K is given. What will happen to salt of weak acid? This will again react with H2O, right? Because obviously it will be in solution. Okay. So this reaction is hydrolysis reaction. This is basically your hydrolysis reaction KH, and this is what you have to answer. So what's the formula for KH? Tell me. Or basically it is reversible reaction. It is reversible reaction. So basically 1 by KH. You are asked to find 1 by KH. So what is 1 by KH? 1 by KH is Ka by Kw. Got it, everyone? Tell me, got it? Yes or no? Yes or no? Okay, right? Now question number 3. Again, right? Buffer solution. Buffer solution. Yes or no? Now, even if you don't have buffer solution, we know that K1 is equal to concentration of what? H plus. So this is your diabasic acid, which is H2CO3. H2CO3 will give what? HCO3 minus plus H plus, right? For this it will be K1. Now again, HCO3 minus will give again H plus plus CO3 to minus, right? Now, what is given? pH is given. Concentration of H plus is given, right? Concentration of H plus. What is concentration of H plus? Tell me 7.4. 7.4 is basically 8 minus 0.6, right? Agree? Tell me, agree? Which is 8 minus log 4. Right, everyone? Okay. So if you, sorry, this is pH. Sorry, this is pH. Okay, pH. Now, if you talk about concentration of H plus, it will be what? It will be 4 into 10 power minus 8. So concentration of H plus is given, right? Concentration of H plus is given. Yes or no? Now think about this. Think about this, right? Think about this. If you see first reaction, so K1 is equal to concentration of HCO3 minus into concentration of H plus divided by concentration of H2CO3. Agree, everyone? Tell me, agree? Yes or no? Yes or no? So this is your conjugate base and this is your acid, right? You are asked to find this ratio. So I can say that concentration of HCO3 minus divided by concentration of H2CO3 is equal to K1 by concentration of H plus. That is the answer, right? Right, everyone? And K1 is given. Concentration of H plus we calculated. So we will get the answer. Third one solved. Fourth one. Everyone, let's see question number 4. Now, when you talk about question number 4, again, what is the reaction? Hydrolysis. Hydrolysis. This is base, weak base given. So KH, what we know, write down what we know. KH is equal to KW by KB. But we have Ka and this KB. Okay. Now, this is degree of hydrolysis of salt, weak acid and weak base. Right? Weak acid and weak base. Sorry, mixture of weak acid and weak base. Then KH is equal to KW by Ka into KB. Okay. Right, everyone? And we know that for this H is equal to root KH. I hope all of you remember this. Yes or no? I hope all of you remember this. Everyone remembers? Just raise your hand. Everyone remember this concept? Mixture of weak acid, weak base. Yes, very good. Okay, so can you solve question number 4? You can solve question number 4, everyone, right? Yes, very good. You can solve it. But now, what if it will be almost comparable to 1? Tell me, what if it is almost comparable to 1? Then what you have to use? You have to use the formula KH is equal to H square by 1 minus H whole square. Yes or no? Yes or no? Tell me. If using this formula, if KH is almost equal to 1, then you have to use this formula. I hope everyone remember this. Everyone remember this? Right? Right, everyone? So that is the step. Okay. Now fifth one. Let's see question of fifth. What type of solution is it? Tell me. Weak diprotic acid. Now don't you think that this is almost the same that we have solved? Right? This is not the problem of buffer or hydrolysis. This is problem of 8.1. So 8.2. Agree, everyone? This is a problem of 8.2. A simultaneous equation. Simultaneous equation, yes or no? Right? So K1 is equal to concentration of H plus into concentration of HCO3 minus divided by concentration of H2CO3. And K2 is equal to concentration of H plus into concentration of CO3 2 minus divided by concentration of HCO3 minus. Right? Agree? Agree? But if you see here, this and this, it is very small as compared to this one. Yes or no? Yes or no? Tell me. Agree? So can I say that most of the H plus is coming from first reaction? Most of the H plus is coming from first reaction? Yes, raise your hand. If you agree with this, just raise your hand. Can I say that the most of the H plus is coming from first reaction? So I can ignore the concentration of H plus from the second reaction. So concentration of H plus from the first reaction. Again, it's a weak acid, dissociation of weak acid. Same formula, K1 into C. Can we calculate? Tell me, concentration of H plus using this formula. And if we put it over here, we know that concentration of H plus, right, is equal to concentration of HCO3 minus from first equation. So this and this are equal, right? This and this are equal. So it will get cancelled, right? So K2 is nothing but concentration of CO3 2 minus. Agree everyone? Tell me, agree? Got this concept? Yes or no? How many of you did not get this concept? Raise your hand. This is the example of simultaneous equation. Do not just listen to me. Try to think in your brain. Try to understand what is happening. Okay. Okay, everyone. Okay, so I guess everyone got this. I'll just repeat once again. Okay, since the value of Ka between 1 and 2 is very huge, right? It's more than 10 to the power 7 times. So the degree of dissociation of second reaction will be very less. So suppose this is alpha dash, this alpha. So alpha dash will be very, very less than alpha. So I can ignore the concentration of H plus from the second reaction. So the concentration of H plus from the first reaction can be given by just formula, which is root K1 into C, right? Now, the concentration of H plus, right, and the concentration of HCO3 minus will be same almost because this alpha dash is negligible, right? So this will be cancelled. So concentration of CO3 2 minus is just equal to K2. Now second one, sixth one, tell me sixth one. Salt of weak acid, right? Yes or no? Salt of weak acid, K2 is given, right? What is the formula for pH? Write down the formula, half pKw plus pKa, right? Plus log A. This is the formula. Formula putting getting, yes or no? Yes or no? Tell me everyone, yes or no? Is it formula putting getting? Okay, right? Now, seventh one. How many moles of sodium propanoate, right? Again, sodium propanoate. So, weak acid salt should be added to 1 liter of aqueous solution containing 0.2 mole of propanoic acid. This is weak acid. Weak acid to obtain a buffer solution of pH 4.7. So again, pH is equal to pKa plus log salt by acid. Formula, pH is given. What is pH? 4.7. K is given. What is pKa? pKa is 5 plus log salt by acid. Right, everyone? Tell me. Okay. So I can say that log salt, you have to find concentration of salt. So X, you have a concentration of acid 0.02 mole in 1 liter, which is 0.02, is equal to, this is minus 0.3. Okay. So X by 0.02 is equal to what? We know that minus 0.02, I'll write like this, minus 0.03 is equal to what? This minus log 2. Agree everyone? Agree? Right? So I can say that X, or you can just say that 0.02 by X is equal to 2. So X is equal to how much? 0.01. That's the answer, right? That's the answer, everyone. First one. Got it? Yes or no? Just raise your hand. Everyone got this? Raise your hand, everyone. Okay, very good, everyone. Right? Very good. Now, second one. What will the pH? It's 0.05 mole HCl. Now, if you remember, if you add HCl, if you add acid, acid. Whose concentration will be reduced? Salt or acid? Tell me, whose concentration will be reduced? Tell me, everyone. Tell me. Salt will be reduced, no? Because salt will react with acid. So it will be A minus X by B plus X. I hope everyone remember this concept. Yes or no? I hope everyone remember this concept. Right, everyone? Anyone have any issue on this? So what is X? X is 0.01. X is 0.01. No, sorry, 0.005. 0.005, right? So pH is equal to pK, which is 5, plus log A. What was A? We have calculated, right? We have calculated. Okay, A was 0.02 or 0.01. 0.01, right? A was 0.01. So 0.01 minus 0.005 divided by 0.02 plus 0.005. Okay, so pH is equal to 5 plus log. I hope all of you can solve this now. Okay, all of you can solve this now, which is 0.005 divided by 0.025. So how many times? 5 times. 1 by 5. Log 5, right? Opposite of log 5. So it will be minus 0.7. So pH is equal to pH is equal to 5 minus log 5, which is, tell me, 5 minus 0.7, 4.3. Okay, see, even if we add 0.005 mole of HCl, okay, the pH changes less. Okay, now third one, same you can solve. Third one is just the ratio, right? Third one is just the ratio. Now level 2 completed, right? Okay, guys, try level 3. Okay, we will discuss level 3 in advanced class this week on Saturday. Wait, Saturday or Thursday? I'll just let you know. Okay, now homework, everyone. Homework of 8.3. Question 1, 2, 3. Any doubts? 1, 2, 3, everyone. 1, 2, 3. Guys, any doubt in question 1, 2, 3? Please ask. Please ask everyone. 1, 2, 3. Any doubts? Homework. Okay, 1, 2. Let's see. Aspirin is a derivative of salicylic acid, weak acid, right? Given. Calculate the ratio of concentration again, right? It is a mixture of weak acid and its salt, so it is your buffer. It is your buffer. Okay. Now, if it's a buffer, so I can say that pH is equal to pKa plus log salt by acid. Now you're asked to find this. Okay, pH is given 2.4. So 2.4 is equal to 3 plus log salt by acid. So log salt by acid is equal to minus 0.6, which is equal to log 1 by 2. Right? So salt by acid is 1 by 2 given. Okay. So question 1 solved. Question number 2, calcium lactate, again salt of weak acid, right? Concentration of salt is given. POH is given, calculate Ka. Okay, right everyone? Right? Now let us think what we have to do in this. Now salt, only salt is given, only salt. So if only salt is given, what is the process? Hydrolysis? Yes or no? Yes or no? Tell me everyone. Yes? So formula, what is the hydrolysis formula of weak acid? POH is equal to, right? If you don't remember, POH is equal to pKh minus log C. If you don't remember, which is half pKb, right? pKw minus pKb minus log C, right? Now you must be thinking, sir, we have to find pKa. Why are you doing pKb, right? And here salt is of weak acid. Sorry, it will be pKa, weak acid, na? pKa, right? So it will be pH only. Okay, pH only. But pH is given. So pH you can find now. pH is equal to 11. Sorry, 14 minus 5, which is 9. Right? So this is 9 given. Okay? Right, everyone? Right? pKw we know. Log C we know. pK, right? pK we can find. Okay, everyone? Yes or no? Okay? So let's calculate. So 9 is equal to half 14 minus log Ka pKa. Right on pKa. Right? Minus log C. It is 0.01, 0.05 into 50. Okay, so calculate this. But here it is CaLa whole twice. So 2 moles it is giving. Right? 2 moles it is giving. Yes or no? 1 mole of salt will give 2 moles of acetate ions. Okay, so the concentration will be twice. The number of moles will be 0.5. Okay, 0.5. 0.5 divided by this, 0.5 divided by 500 into 1000, right? 10 times. So it will be what? 1. So log 1. Log 1. So it will be 0. Okay. So obviously you can calculate 18 is equal to 14 minus pK. So you can calculate K. It's easy. Okay, everyone. pK you can calculate. pK is equal to how much? pK is equal to minus 4. So Ka is equal to 10 to the minus 4. Solve question number 2. Now third one. Okay, so it is already given that third is a buffer. Equal concentration. Kb given. So it's easy now. Tell me. POH is equal to PKB because equal concentration. So log x minus by hx, right, will become 0. Right, everyone? Right? Okay, sorry, it's acid. So pH is equal to pKa. But Kb is given. Kb is equal to what? 10 to the power minus 10. So Ka is 10 to the power minus 4. Right? So pH is equal to, tell me, log of this, which is pK4. Okay? So third one is easy question. Okay, now let's see. 2 to 9, sorry, 4 to 9, everyone. Question 4 to 9. Please ask so that I can know that you have solved or not. No one is asking. Okay. Salt of weak base, hydrolysis, right? It will release what? OH. So POH is equal to half right? If you don't remember the formula, right? KH minus log C. And for weak base, KH is equal to KW by KB. So POH is equal to what? Half PKW minus PKB minus log C, right? And H is equal to root KH by C. So these are the formulas, right? Now what is given? pH is given. So pH is given, so you can find POH, right? pH is given, so you can find POH. You can use it in formula. Concentration is given. You can find PKB or KH. Okay, right, everyone? Then you can find what? You can find H. Now, fifth one we have solved, right, everyone? Fifth one we have solved already. Tell me yes or no. Yes or no? Fifth one we have already solved. Okay, it's exactly the same question. Okay, fifth one is exactly the same question that we solved in last in class. Sixth one. Tell me sixth. Again, formula putting getting yes. Tell me yes. Agree. Formula putting getting sixth one. KB is given, concentration is given, pH is given. You can find POH. Sorry, salts of weak acid is there, right? So urea, na? Salt of weak base. Okay, sorry, salt of weak base. So anyways, you can calculate POH first. Okay, then you can just calculate pH. Formula putting getting this one. Okay. Now seventh one, see question number 7. Sodium formate is added. Sodium formate, salt of weak acid, to 1 liter of 0.1 formic acid buffer solution, right? Whose K is given. How many times H plus concentration of acid diminish assuming the salt is completely dissociated? Okay. Now think about this. First, you have to calculate what is the concentration of H plus. Initially calculate H plus. So what's the concentration of H plus? Basically, for weak acid, concentration of H plus is given by initially, if sodium formate is not given. Initially, sodium formate is not given. Then H plus is Ka into C, right? This is initial H plus, which is root 1.8 into 10 to the power minus 4 into C, which is 0.2. Got it, everyone? Tell me yes or no. Yes or no? Initial H plus, because the question is how many times it will diminish after salt is added, okay? Right? So this is H plus initial. So 1.8 into 0.2, 0.36, right? So this will be 6 into 10 power minus 3. Okay, molar. Now, after it will become buffer, after it is becoming buffer, right? We can say that after becoming buffer, H plus is equal to Ka into concentration of Ha divided by concentration of A minus. This is what we have studied, right, everyone? Now, K is already given 1.8 divided by minus 4 into Ha. Ha is concentration of acid, which is given as 0.2. Why I'm not using the formula? Because it is given only, na? I have to find H plus concentration only. Why to take log and then convert back into this? Concentration of A minus is 0.1 divided by 1. So 0.1. Got it, everyone? So from here, if you calculate, right, again 2. Okay, so this is equal to what? 3.6 into 10 power minus 4 molar. It is H plus final. So take the ratio, you will get the answer. Take the ratio, you will get the answer. Okay, everyone? Tell me, final divided by initial. Everyone got question number 6? Sorry, 7. Raise your hand. Everyone got question number 7? Raise your hand. Okay, everyone. Very good. Very good, everyone. Question number 8. Now 8. 8 is same as, 8 is ditto same as question number 5. Agree? Tell me. 8 is ditto same as question number 5. Instead of H2CO3, we have H2SO4. So H2S. Guys, can you follow? 8 is same as question number 5. Ditto same. Right? No difference. Agree, everyone? Right? Agree? Tell me. Yes? Yes or no? Please respond. 8 is same as question number 5, right? Ka1 and Ka2, same question, right? Very, Ka1 is very greater than Ka2. So H plus from second reaction will be ignored, right? So for first reaction, concentration of H plus is given by root Ka1 into C, right? Same formula putting getting, okay? Okay, now last question, question number 9. Okay, last question, question number 9. Now see this, see, NaOH was dissolved in 1 liter solution containing 1 mole of acetic acid. Weak acid, right, plus strong base. Tell me what kind of reaction it is. If you remember, if you have weak acid and strong base, it will form what? If it is a limiting reagent, we will get weak acid plus salt of weak acid. Right, everyone? Tell me, right? What is this? Tell me, what is this? Is it a buffer? Is it a buffer? Yes or no? Okay. Sorry, this is already given. 1 mole of acetic acid and 1 mole of sodium acetate is already given. So this is added. Now, it is already a buffer. Sorry, it is already a buffer. So for buffer, what is pH? pH is equal to pKa plus log A by B. A by B, solved by acid. Now this is added. 4 grams of NaOH is added. So we know that molecular weight of NaOH is 40. So number of moles of NaOH is equal to 4 by 40. 1 liter. So it is basically 0.1 molar, right? So if it is added, now think about this. If base is added, which will be consumed? Salt will be consumed. Salt will be consumed or acid will be consumed? Tell me, salt will be consumed or acid will be consumed? Reply, everyone, please reply. Am I teaching myself? Salt will be consumed, na? So it will be, salt will be consumed, sorry. So salt, concentration of salt will be decreasing. So it is A minus X, which is this one, and B plus X. Sorry. Acid, base will react with acid. So acid will be consumed, right? So A and B equally, it was 1 mole and 1 liter. So 1. So pH is equal to pKa, which is 1.8 per minus 5. It is given, right? What it is given? It is how much? 5 minus log 1.8 minus log C, which is 1 plus 0.1 divided by 1 minus 0.1. Okay, everyone. So can you calculate? Tell me, can you calculate pH? Yes or no? Tell me, yes or no? Okay. Okay, everyone. Tell me, all of you understood till this point? Raise your hand. If you understood till this point, please raise your hand. Okay. Okay, everyone, very good. Very good, everyone. So we will play one Kahoot, one small Kahoot. Okay, right? Now, 8.4 is given as homework. Okay, so we will discuss 8.4 as well as TPP1. Okay, 8.4 as well as TPP1 in Wednesday's class. Okay, everyone, tell me. Okay, right? Okay, let's see. Let's play one Kahoot on solubility. 24 answers, 17 are correct. Very good, everyone, right? Very good. So most of you got the correct answer. Very good, everyone. Okay. Okay, everyone. Very good. Next, KSP of Z are 3, P of a whole 4 in terms of solubility, in terms of S. Again, very easy question, everyone. Tell me. Yes, very good, everyone. Very good, right? So all of you got it correct, right? If you see the reaction will be 3, right? 3s to the power 3 into 4s to the power 4, right? Okay, very good. Next, take your time, everyone. Calculate the concentration of OH, which is your S, here to S, right? Then you can calculate pH, okay? Same concept. Okay, everyone. Yes, very good. Most of you gave the correct answer, right? So from here, we can see that this is KSP is equal to how much? 4S cube, right? And concentration of OH minus is equal to 2S. So from here you can calculate S, then OH minus, okay, then you can calculate pH. Next, this question we have done, right? This question we have done in everyone. This is just a conceptual question. No issue, Samarth. Message in the chat box. Don't worry. Okay. Yes. Yes. Right, everyone. Because I can say that in this there will be greater common ion effect of Cl minus ion. Right, everyone? As compared to AgNO3. Okay, and the concentration of NaCl is more than that of the AgNO3. So common ion effect will have role in this question. Next, again the problem of common ion effect. Right, very good everyone. Most of you are correct in this, right? Again, it will act as a common ion, right? So Ksp is equal to concentration of Ag plus whole square into concentration of CO3, which is taken from here, right, everyone? So I can say that Ksp is equal to 2s square into 0.1, right? Calculate, you will get the value of S. Okay, next. Again, simple problem, everyone. Please try. Okay, Samarth, very good. 19 answers till now. Okay, same as last question, everyone. Same as last question, right? So it is 4s cube is equal to Ksp. So you can calculate S from here, and F will be 2s, right? Okay, next. Okay, Sneha. Only 5 answers. How come? See, solubility of AgBrO3. So in this it is Ag, then BrO3 minus. Okay, right? Right, everyone? So here you can calculate S, right? This divided by 236, right? Because it is in 1 liter. So S you can calculate. So KSP is equal to S square. As simple as that. Okay, everyone, right? That's it. Next. Okay, Samarth. Okay, very good. Second last problem, everyone. Think about this, everyone. Think about this. Okay, Samarth. Yes, Na2CO3, right? Let's see. Last question. Okay, everyone, last question. Guys, you can calculate the concentration of OH minus from here, right? POH is 2. So OH minus concentration is 10 to the power minus 2, right? Which is 2S is equal to 10 to the power minus 2. So you can calculate S, right? So KSP is equal to 4S cube, as simple as that, right? Okay, let's see the podium, everyone. Sneha, third position, very good. Second, Abhiram. Very good, Abhiram. First, Aryan. Aryan. Very good, Aryan. Who are the runner-ups? Meet and Khushi. Very good, Meet. Very good, Khushi. Thank you, everyone. That's all. Right? Bye, everyone. Bye, everyone.